So we just found in the previous video the standard deviation of some population, and the population was only 5. Nothing say the population can't be 5, right? In some places in the world, that's all they have in the village, 5 people. Anyway, we have a standard deviation problem here. We're taking basketball players, 4 basketball players from a team, and I'm listing their heights in centimeters. It's just easier to find. So we have 184 centimeter in height. One player has that height, another one 194 centimeters, another one 199 centimeters, and finally somebody we picked is 215 centimeters tall. All right, so these people are all over 6 feet. That's the whole idea here, from about 6 to 7 feet somewhere. And we want to find the standard deviation of this particular sample. Well, we're going to go over the same process that we had before, right? We're going to go over the same process that we had before by finding the average. So I'm going to just erase the top part so you can still see the values. And I'm going to find the average of these values, the mean. So step 1 is to find the mean of these values. So I take 184, I add it to 194, then I add 199, then I add 215, and I divide that by 4 rather. So if I divide that by 4, what I come up with, you should have a calculator with you too. Okay, the memory was on here, so I have to do this again. 184 plus 194 plus 199 plus 215. And I'm going to divide that by 4, and I'm going to get 198. So the mean height here is going to be 198 centimeters, all right? And what I'm going to do, I'm going to go over the same steps that happened. So because you saw the steps in the video, what I'm going to do now is I'm just going to throw in the caveat, right? So the caveat here is that when I get these values, I'm still going to do step 2. I'm still going to do the subtraction. So I'm going to be doing 198 minus 184, and I'm going to get 14. I'm going to be doing 194 minus 1.
8.
Yeah, sorry about that. It's a lot on the mind. What we should have here first is we should have the value first. So it's 184 minus 198, and that's going to be negative 14. The next one is going to be 194 minus 198, and that's going to be negative 4. And then we're going to have 199 minus 198, and that's going to be 1. And then we're going to have 215 minus 198, and that's going to be 17, I think, right? So you can kind of see, just want to make a quick comment. This is basically showing you that some of the players obviously are shorter than the average here, right? And then some of the players are taller than the average. That's where the positive and negative values come from, right? So what we're going to do now, we're going to go to step 3, which I'll write above. And step 3 just involves squaring these things, right? So I'm going to take the square of these values. So negative 14 squared is going to be, I think, 196. Negative 4 squared is going to be 16. 1 squared is 1. And 17 squared is going to be, I think, 289. You can check me in the calculating device. And so here I have the squares of these values. And then I finally get to step 4. So what is step 4? I'm just going to basically take the sum of these squares, right? So I'm going to add all these values up to step 4. Sorry about that. And then, forgive the way this is written. So I'm going to be adding, and again, calculators are good. So I'm going to be adding 196 plus 16 plus 1 plus 289. And I'm going to get 502. All right. And so what I'm going to do, I'm going to do the same thing that I did before. I'm going to take the, use this, and I'm going to try to take some square root. However, this time what I'm going to do is I am not going to be taking the square root of 502 divided by 4. I'm going to take the square root of 502, the square root of this quotient, 502 divided by 4 minus 1. So what happens here is if you know that what you're dealing with is a sample from a larger population, you divide by 1. And so when I do that, I'm going to get 502 divided by 3. And I'm going to take the square root of that thing. Alright, so the square root of 5, what's going on here? Of 502 divided by 3. Alright, and so I'm going to get approximately 12.9, right? So it's approximately 12.9. So this standard deviation is different from the one before. This is called sample standard deviation, alright? And so this is a sample standard deviation. And there's a formula that we haven't seen before. Again, you're going to be supplied with the formula on the exam. So the formula for this that we have here to find the standard deviation is going to be the square root of, this time we have our x minus xi minus x bar. So we're using x bar now. Squaring that divided by n minus 1. In this case, this is what our standard deviation is, right? I'm going to write that now as SD for lack of a better term, alright? And so this is how we find standard deviation for a sample.